Okay, this is Notes Rational Functions Day. This is actually day 2. Day 7, you can probably say, because we've been doing this for so long. But this is actually applications with rational equations, not functions. They actually have an equal sign. So here are your learning objectives, here are your standards, and here is what we are going to be basically using. So when you are doing a job, you are doing work. And what basically dictates what work you are doing is the rate you're doing it and the amount of time that you do the work for. So what we say is that we have work is equal to a rate times a time. Well, what we're going to be doing is we're going to be using kind of a variation of this. Your rate is basically going to be what work you're doing over time. And so it's going to be a constant formula that's going to be used throughout. And this is the main thing, because what we're going to be doing is we're going to be having a job that you're doing or work that you're doing over an amount of time plus another, or the same job or a different job over this another amount of time. That equals maybe the two working together. So maybe you're working with a friend together. You want to see how long it might take you, or estimate how long it might take you to do a job as one. So we're going to kind of jump right into this. So here is our job, our first set of jobs. So we have a bricklayer can lay or can build a wall of a certain size in 5 hours. Another bricklayer can do the same job in 2 hours. If the bricklayers work together, how long would it take to do the job? So what we have is we have work. So the way I say this, and the way that's going to hopefully make sense, is you're doing one job. You can say one bricklaying job, and you're doing it in 5 hours. So that's bricklayer 1. Plus another bricklayer, so this is bricklayer 2. So bricklayer 2 does that same job all over 2 hours. So that's job 2. We're trying to find out if the bricklayers work together, how long would it take? And again, this is a formula that you can use to kind of estimate how you would do. So again, you're doing that same job. So it's 1 and 2. All over the time that it takes. We're trying to find, we do not know, we say it's X hours for 1 and 2 to work together. So now, what I have is I have 5 hours, I have 2 hours, and I have X hours as my denominators. So we have basically to do, once the setup is done, that's the tough part about this, is the setup, we find our common denominator. So we don't worry about restrictions in this case, because most of the time you're not going to run into restrictions because you can't work for 0 hours. That would be the restriction here. So here you're trying to find out 5, 2, and X, what the common denominator is. So the common denominator in this case would be 10 and X, because 10 is the number that 5 and 2 both go into, and then you have X. That's your LCM. And you're going to do this the exact same way you did your rational equations in the previous section. So what I'm going to do is I'm going to multiply every single part by 10x. Every single part by 10x. And every single part by 10x. The only thing that you're multiplying, don't worry about the jobs 1, jobs 2. I'm putting that, and it's one of those things that I'm probably going to take it away for the next few so it's not as confusing. You just need to know this part, what is the work and what is the time. So if I do this on the top, I have this becomes 2. You have 2 times x times 1 gives you 2x. Plus 2 goes into 10 5 times. 5 times x is 5x. 5 times x times 1, and that's that. So now we have that, and we say that equals, the x's cancel out here, so you're basically canceling out the denominators. That equals 10. If I add these together, we got 7x equals 10, and we have x equals 10 over 7, which is approximately 1.43. Now, since we're finding the unknown on the bottom, it's 1.43, and it would be hours. So if these two bricklayers worked together, one would take 5 hours, one would take 2 hours, but if you work them together, they would take an hour or 1.43 hours, which is roughly about an hour and a half. Okay, so the same deal here. There's going to be a little bit of a wrinkle here, and just because I think I'm actually going to put the work A, because what you want to do is make sure that you are consistent throughout. So we have on a conveyor belt, or one conveyor belt can move 1,000 boxes in 6 minutes, and we have another can move 1,000 boxes in 11 minutes. If another conveyor belt is added and all three are used, the boxes are moved in 3 minutes. If the third conveyor belt worked alone, how long would it take to do the same job? So we have our first part, 1,000 boxes in 6 minutes. So the work is 1,000 boxes in 6 minutes. That's rate 1. Plus rate 2. Another one can do 1,000 boxes in 11 minutes. 1,000 boxes in 11 minutes. Another conveyor belt. So we're going to have another conveyor belt. Let's go with this guy. Another conveyor belt here is added. So that conveyor belt will do 1,000 boxes, but we have no idea how long, X minutes. But we do know that if all three are used, that it can do it in 3 minutes. 1,000 boxes in 3 minutes. Okay? So, in this case, I need to find my common denominator. So I have my denominator of 6, 11, x, and 3. So the number that all of these go into is 66x, because 6, 11, and 3 have a LCM of 66, and then we have this x that's kind of coming along for the ride. So that's my LCM. So what I'm going to do is I'm going to take my LCM and multiply every single part of this by my LCM. We have 66x. 66x. The setup of it is the tough part. Solving of it should not be too bad. And then 66x. Okay, so we're going to do the first part here. We have 6 goes into 66 11 times, so we have 11. And we have 11x times 1,000, so we have 11. 1, 2, 3 x, and that's boxes, plus we have boxes and then the rate as well. Then we have this goes into this 6 times, and then we have that times 1,000, so we have 6,000 x, plus we have the x's cancel out here, and you're left with 66,000. And no x, we equal. This guy goes away with this, which is 22, and we're left with 22,000 and an x. Now, these are big numbers, but I'm going to do a trick here. That literally the reason I put the 1,000 boxes up here is because conceptually you need to know it's 1,000 boxes is your job. But I can divide all of this by 1,000, and these guys go away completely. So I'm left with much nicer numbers. So I have 11x, 6x, and that gives you 17x, plus 66 equals 22x. And I'm going to subtract. I get 66 equals 5x, and I divide, and I get 13.2. Now, what are my units for 13.2? We have to look and see where my x value was. It's minutes, so it's 13.2 minutes, and you're done. So that means that third conveyor belt will take 13.2 minutes to do 1,000 boxes on its own. Okay, next order of business, same type of mentality. So we have Adam, Bethany, and Carlos. So we have 3 at once. So we have Adam, or to paint a particular house alone, Adam estimates it would take him 4 days. Adam is 4 days. So one house is 4 days. Plus, we have Bethany is 5.5 days. So one house in 5.5 days. plus Carlos can do it in 6 days. So one house in 6 days. That equals, if these estimates are accurate, how long would it take the 3 of them to paint the house together if they work together? So the work together is one house, but we have no idea how many days. X days. So what you're going to do is you're going to try and find your common denominator between 4, 5.5, 6, and X. The trick to finding the common denominator, you don't have to necessarily find the LCM with these. What you can do is literally just take all of these numbers that you see and multiply them. And that will give you the common denominator, or it might not be the LCM, but you just need a denominator that will actually work. So if I take 4, 5.5, and 6, if I multiply all of these straight across, that will give me 132, and don't forget your x from here as well, so it'll be 132x is my denominator. So, and again, I'm not concerned with if it's the LCM, because I just need something to clear the fractions with this, so that's kind of a shortcut trick, because most of these are going to be whole numbers with one variable. So I'm going to multiply every single one of these by 132x, 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 and 132x. So canceling these out, I've got 33x plus 5.5 into this goes 24 times, so we got 24x plus 6 goes into this 22 times 22 x's, or 22 x's, and then we have that equals x's cancel out, so you're left with 132. If I add these all together, I got 79x, and that equals 132. And I divide, I got x is equal to 1.67. So again, one of the reasons why you want to get into the swing of things, of making sure you know where this occurs, 1.67, it would be days. Your units is going to be part of your points, so you need to make sure you know that. All right, fourth one, we got a few more left. So we have Tim and Ashley mow lawns together. Tim, working alone, can complete 1 lawn in 2 hours. So you get to the point where you can actually just say 1 lawn, 2 hours. And if you want to do lawn, hours, plus, that's fine. Ashley can complete 1 lawn alone in 3.5 hours. So 1 lawn, 3.5 hours. That equals, how long does it take them to complete 15 lawns? This is why you need 15 lawns. So 15 lawns all over X amount of time. We have no idea. So what you're going to do here is you're going to make sure that your common denominator, in this case, like I said, the trick is just multiply the denominators, 2, 3.5, and x. That gives you 7x for your common denominator. So I'm going to do 7x, and you multiply every part. That does not change. That's exactly like the clearing of the fractions, 7x. So the first part, that goes 3.5, and you're left with 3.5x. Plus, that goes 2, you're left with 2x. That's an equals. That guy goes away. You're left with 105, and no x, because that's basically it. And then I add, and I get 5.5x equals 105, and I get x is equal to 19.09. And where are my units? Where am I trying to find this? Hours. So that'd be hours here. You need to make sure you have your units. That's probably going to be a point on the question. So 19.09 hours is when they work together. All right. So if you want to pause the video and try this one on your own, like I said, it's going to be one of those things. This one involves a little bit of algebra, as all this does, but you have, instead of numerical values for some of them, you have algebraic that you have to kind of decipher. So it says you can stuff envelopes twice as fast as your friend. So if you do X, your friend does it in 2x. Not you, because again, this is time. So you're doing twice as fast, which means that you're going to be the smaller time. So that means together you can stuff 6,750 envelopes. So if we have 6,750 envelopes for a time of, so E, for a time of X plus 6,750 envelopes for a time of 2X, that equals 6,750 envelopes for a time of 4.5. And you're going to do the exact same thing. Now, again, if you noticed in the previous part when it was 1,000 boxes, I could actually get rid of these by dividing by 6,750. If that confuses you and makes that all one, do it at the absolute end, or you don't even have to do it at all. You're still going to get the same thing, but it's just going to be bigger numbers. So I'm going to multiply the x, the 2x, and the 4.5 to figure out what my denominator is. You multiply only the numbers, which would be 9, and we just have 1x. That's all we need. We don't want to run into quadratics here. And then you multiply each one of the denominators, or I'm sorry, numerators by 9x. 9x and 9x. Okay, so when we do this, the reason I'm going to actually divide by 1,000 here and just say these guys go away, I divide by 6,750, that basically creates 1, is because I'm going to end up with much nicer numbers here. That gives me 4.5, so I got 4.5. That equals 2x. And then I solve. 13.5 equals 2x, and you divide by 2 to get x equaling 6.75. And again, this is on the bottom. This is ours. This is ours. This is ours. I should have put that in the first part, but hopefully you forgive me. So this means 6.75 hours. That means you take 6.75 hours. This is going to be twice that, which is going to be 13.5 hours. And you don't have to write it in a sentence. I didn't say to do that. You can if you want to, if it helps you. That's it. That's all. All right, if you want to pause this one and work this one out on your own, you can. So we have Mary can decorate the day's cookie supply 4 times as fast as Kate. If they decorate all the cookies working together in 28 minutes, how long would it take for each of them to decorate the cookies individually? So we have a batch of cookies. One batch is 4 times as fast as Kate. So 4 times as fast means that Mary is going to be x. That means Kate is going to be 4x because it takes 4 times as long. So 1 over x, that's time, and it's minutes, plus 1 batch in 4x minutes equals 1 batch in 28 minutes. Okay, so the common denominator here, you could multiply the 4 and the 28 and you get what, 112. You could do that, but I want to do a smaller one. I think there's a smaller one. There is a smaller one. 28 is what 4 and 28 both go into, and we have an x in common as well as part of it. So we have 28x as my LCM, 28x, and 28x. The LCM is always the easiest way, but if you're one of those ones like just get me through this, multiply the numbers that you see, and you'll get ones that work. You just have to make sure you divide the bigger numbers. So these guys go away. You're left with 28 plus 7 equals x. So you have 35 is x. Now what is the 35? Well, it's minutes. So that means Mary can do it in 35 minutes. And we have Kate is 4 times that, which is 140 minutes. And that is it. That is your work problems that you're going to be doing.